So what do we know about scientific notation? A number is in scientific notation if it is written in the form of a times 10 to the nth power, where n is an integer and a is greater than or equal to 1, but less than 10. We use powers of 10 for scientific notation. First thing we're going to talk about is how to take scientific notation and put it into standard form. If you look at my first example, it says 10 to the 6th power. The 6 is a positive. That positive means we're going to move the decimal to the right. Every time we move the decimal to the right, we're multiplying by a value of 10. So as you can see here, I moved it over 1, 2, 3, 4, 5, 6. And that's where the decimal should end. That means I now have to add zeros in the spots that are blank, making our final answer for this 126,000,000, which when you add the commas is 1,260,000. If you look at the next problem, we have the exact same a, which is 1.26. But this time the exponent is a negative number. That negative tells you you're going to move to the left. Every time that you say a negative number, you're not multiplying by a value of 10, you're actually dividing. So we're going to move this over 1, 2, 3, 4, 5, 6 times. Each one of those represents dividing by a value of 10 or multiplying by 1/10. Just like when we multiply with a positive, we're going to fill in the blanks with zeros, making our final 0.0000126. Now we're going to take standard notation and turn it into scientific notation. In this situation, we want to ask ourselves, where did the decimal start? Keeping in mind that a has to be greater than or equal to 1, but always has to be less than 10. So as I look at the final answer, 9,362, I ask myself, where did the decimal begin? The only place the decimal could possibly begin is after the 9. So it would be 9.362. The question is, how did we get to that point? Well, this is where my decimal ended, and this is where my decimal began. In order to go from where it began to where it ended, I would move to the right. That allows us to know that our power of 10 is going to have a positive exponent. And as I go over 1, 2, 3, that positive exponent is a 3. Looking at this one, where could my decimal start? It would not start in front of the 3, but behind the 3. Because again, a has to be greater than or equal to 1, but less than 10. So therefore, it would be 3.675. Again, times 10 to the value of some exponent. So if it began behind the 3, where did it end? Right there. That means I'd be going to the left. 1, 2 spots, and therefore my exponent would be 10 times to the negative 2 power. After that little tutorial, I want you to look at these 4 values, and I want you to put them in order from least to greatest, keeping in mind what it means when the exponent is a negative value and when the exponent is a positive value. So please pause the video and put them in order. Now that you've put your answer, it's time to unpause the video and check it with my answers as below. 9.8 times 10 to the negative 5, 1.1 times 10 to the negative 1, 2.4 times 10 to the negative 1, and then lastly 1.6 times 10 to the 3rd power. Now we're going to combine our scientific notation with our exponent rules that we've been working on. In the first question, you can see that I'm multiplying 2 by 4 times 10 to the 3rd power. In this particular case, when we're multiplying the 2, we're only multiplying the 2 by the 4. We are not going to multiply the 2 by the 10 to the 3rd power. Therefore, our answer would be 8 times 10 to the 3rd power. We need to double check that our a is greater than or equal to 1, but less than 10. And since 8 does fit that, we're able to leave it as 8 times 10 to the 3rd power. As we look at number 7, we notice that there is division happening. In this particular case, we are dividing a scientific notation value by a scientific notation value. And this is where our exponent rules come into play. We have 24 times 10 to the 7th over 6 times 10 to the 2nd. We apply our exponent rules to this. That means we're going to actually divide the 24 and the 6 to get 4, but we're actually going to subtract 7 minus 2 in the exponents because the powers of 10 are the same, making our final answer 4 times 10 to the 5th power. We need to make sure that that value of a does go along with the limitations of being greater than or equal to 1 but less than 10. And 4 is greater than or equal to 1 and less than 10. So we're able to leave our answer as 4 times 10 to the 5th power. Now let's look at the next two examples. We have 6 times 10 to the 2nd power times 7 times 10 to the 5th power, but all of this is combined with multiplication. Again, we can use our exponent rules by combining like terms. So 6 times 7, and therefore 10 to the 2nd times 10 to the 5th. When we do that, we end up with 6 times 7, which is 42, and 10 to the 2 plus 5. When we look at that, we end up with 42 times 10 to the 7th. The problem here, though, is our a is not less than 10. So therefore, we actually have to move it one more spot, making it 4.2 times 10 to the 8th power. Since we had to take 42 and make it into 4.2, that's why our exponent went from 7 to 8. We ended up having to add a place value to it. Therefore, to clarify that it is actually fitting that a is less than or greater than or equal to 1 and less than 10. In our next problem, just like a previous problem, we are looking at this as division, but we're only going to be dividing the 2 by the 0.3. So 0.3 divided by 2 ends up giving us 0.15. 0.15 times 10 to the negative 9 does not hit our limitation for a. Therefore, we need to change the exponent and also change our a. Our a actually has to be 1.5. Therefore, we need to move it over a space, so we're going to subtract 1, making it 10 to the negative 10. Now that we've done a few examples, it's time for you to try these problems on your own. So please pause the video and try 10 through 15. Keeping in mind that 10 through 11 is multiplication and division with scientific notation. 12 to 13 is scientific notation to standard notation, and then from standard notation to scientific notation. So please pause the video and do those problems. Now that you've actually done these 6 problems, it's time to see if you got them correct. So here are the answers. For number 10, you end up with 4.2 times 10 to the 3rd. For number 11, you ended up with 17.5 times 10 to the 14th, but that is need to be turned into 1.75 times 10 to the 15th. In number 12, you were told to move to the left from the negative, so 0.000486. In number 13, you were told to go to the right because of the positive, making it 520,000. And then, in this one, your base of A had to start with 6.1. It ended over here, which means you went to the left, giving 6.1 times 10 to the negative 6. And here, you cannot leave it because it's 32.4, where it needs to be 3.24, therefore making the exponent a negative 4 for the 10. At this point, that concludes our video on scientific notation, and we'll be doing problems in class. Thank you.